Now, good morning to all. Let us start the next lesson, motion in a plane. Today in this lecture, I am going to cover the following topics: scalar and vectors, types of vectors, vector addition, unit vectors, resolution of vector. Now, as you know that scalar is a physical quantity that has only a magnitude, while vector is a physical quantity that has both a magnitude and direction. Example, mass, temperature, length, volume, they are the scalar quantities. Positions, acceleration, displacement, momentum, etc. are the vector quantities. Now, to represent a vector, we always represent it through a straight line having arrowhead. So, arrowhead shows the direction of the vector, the length of the line shows the magnitude of the vector, and by a symbol we can represent it putting a small arrow over it. This is the representation of a vector. So, letter A is the vector A, and arrow shows its the direction and length shows its magnitude. Sometimes the vector represented by their symbol also, like position vector is represented by R vector, velocity by V vector, and force by F vector. Now, types of vector. Now, parallel vectors, if the two vectors they are in the same directions, they are said to be the parallel vectors. If they are in the opposite direction, they are said to be anti-parallel. If they are in the same directions having the same magnitude, they are equal vectors. But if they are opposite in directions but same magnitude, then they are called the negative vector. Collinear vector, if they are in a same line, whether the direction is same or anti. But if they are in the same line, they are collinear vectors. And if they have the same initial common point, initial point, then they are the co-initial vectors. And if they have the common terminal point, then they are co-terminus vector. Coplanar vector, if they are in the same plane, but if they are distributed in space, then they are the non-coplanar vector. Now, if the vectors having the same straight line effect, they are called the polar vectors, like acceleration, velocity, force, etc. But if they have the rotational effect, they are called the axial vectors, and such as angular velocity, torque, angular momentum, angular acceleration, etc. Now, vector addition. The vectors can be added either by the triangular law or by the parallelogram law. Now, if we want to add two vectors, if they represent the two sides of a triangle in the same order, then the third side in the opposite order gives the resultant of the two. This is the triangular law. And in parallelogram law, if the two vectors represents the two sides of a parallelogram, then their diagonal represents the resultant of the two vectors. So this is the parallelogram law. Now, commutative properties, they can be added in either order, either A to B or B to A. So they obey the commutative law. Now, associative law means they can be ordered in either way. Either first we can add A and B and then C to be added in the resultant, or first we add B plus C and then resultant is added to vector A. The final result D is same in both the cases. That means we can say that they follow the associative law. Now, subtraction of the vector. Now, addition means vector A is added to B. Now, in place of B, if we are adding vector minus B to vector A, then result will be A minus B, but it is because of the addition of negative vector of B to vector A. So, subtraction of vector B means the addition of vector minus B to vector A. Now, vector addition analytical method. Now, to analytical method to find the magnitude of the resultant. Graphically, we can simply measure the length of the vector and can find out its magnitude, and as well as analytically we can also find it. Now, suppose P and Q both are the two vectors, they are along the two sides of a parallelogram, then their diagonal gives the resultant. So now we are finding the magnitude of vector OC analytically. In triangle OCM, so in triangle OCM, according to Pythagoras theorem, OC square is equal to OM square plus MC square. OM square can be written as OA plus AM. So OA plus AM plus CM square. Simplifying it, we get this result, that is OA square plus 2OAX, OA cross AM plus AM square plus CM square, and from this AM plus CM gives you AC square, so that can be written AC square. Also in triangle AMC we have cos theta, AM upon AC, so from here AM is equal to AC cos theta. Putting this value in this equation, this will reduce to in this way. Now OA is equal to P and AC is equal, OB is equal to Q. So by putting all these values, we will get the result R is equal to under root P square plus 2PQ cos theta plus Q square. Now the direction also, because without direction the vector has no sense. To find its direction, let it is making alpha angle with angle P. So from the triangle CAM, in this triangle the sine theta and cos theta, we can find out CM is equal to AC sine theta and AM is equal to AC cos theta, and the tangent alpha in this triangle, tangent alpha is equal to CM upon OM. OM can be broken into two parts, OM, so we can say that tan alpha is equal to AC sin theta upon OA plus AC cos theta, or we can say that tan alpha is equal to Q sin theta upon P plus Q cos theta. Now case 1. If the two vectors both are in the same direction, or when the angle between the two vectors is 0, that is theta is 0. So in place of theta we can write cos theta is cos 0 and cos 0 is 1. So the result we will get R is equal to P plus Q. Means if they are in the same direction, their magnitude simply be added, and the direction of the resultant, by putting the value theta in this expression, we will get that alpha is 0, or we can say that when both the vectors are in the same direction, their magnitude will be simply added and the result will be in the same direction. But if the two vectors, they are making angle theta between them, they are perpendicular to them. So when we put theta 90 degree, then cos 90 is 0, and the resultant magnitude will be under root P square plus Q square, and the angle or the direction will be tan inverse Q upon P. If the two vectors, they are opposite to each other, then theta is 90 degree and cos 180 degree is minus 1 degree. So this will reduce to P minus Q. And if P is greater, then naturally P minus Q, the resultant will be in the direction of P. But if Q is greater, then the resultant will be in the opposite direction. So we can say that if P is greater than Q, then alpha is 0, and P is less than Q, then alpha is 180 degree. Now unit vector. Unit vector is a vector whose magnitude is exactly 1 and drawn in the direction of the given vector. That is, if we have vector A, then this is the unit vector. Representation of unit vector is the same letter by putting, this is known as the cap, by putting cap. So A cap is the unit vector of A. Similarly, if we have vector B, then this is B cap. This is a unit vector of vector B. So it has both dimensions and unit, and its purpose is to specify a direction in the space. So unit vector means the magnitude is exactly 1, but it is in the direction of the given vector. Similarly, unit vector, it can be represented because any vector means magnitude and its direction. So magnitude is represented by the simple plain letter A, and its direction is represented by the unit vector. So we can say that any vector can be represented in this manner. Now similarly, the Cartesian unit vectors, that is the vectors along the x-axis, along y-axis, and along z-axis. Along x-axis it is the vector I cap, along z-axis it is j cap, and along z-axis it is k cap. For negative axis minus I cap, for negative y minus j cap, and for negative k minus k cap. So the Cartesian unit vectors, that is unit vectors along x-axis, y-axis, and z-axis. Now resolution of vector means the splitting of a vector into two or more vectors in such a way that their combined effect is same as that of the given vector. That means if vector A, it is splitted into vector A t and vector an, when you add at and an, it will give you the vector A. Similarly, the vector can be resolved along the two x-axis, that is the rectangular component. So vector A can be resolved along x-axis, that is vector ax, along y-axis, that is vector ay. So we can say that vector A is equal to vector ax plus vector ay. Now ax can be represented as ax I cap, ay can be represented as ay j cap. So we can write A is equal to ax I cap plus ay z cap. Also theta is the angle between the vector and the x-axis, then ay is equal to a sin theta and ax is equal to a cos theta. Now if you square and add these two terms, what you will get? Ax square plus ay square is equal to a square, because sin square theta plus cos square theta is 1. So you can say that a is equal to under root ax square plus ay square, that is a is equal to under root ax square plus ay square. And from this direction also can be written as theta is equal to tan inverse ay upon ax. Similarly, we can find the rectangular component along the 3D vectors in three directions, that is vector A can be represented as ax plus ay plus az, ax I cap plus ay z cap plus az k cap, and the magnitude A is under root of ax square plus ay square plus az square. Here ax is equal to a cos alpha, alpha is the angle between a and x-axis, ay is a cos beta, beta is the angle between a and y-axis, and gamma is the angle between y-axis between vector A and z-axis. So in this way we can resolve the component along the three Cartesian axes. Simply we can also add the vectors not only by the graphically but also by the components. So if we have the vector A and vector B, that is ax I cap, ay z cap, az k cap, and B is bx I cap plus by j cap and bz k cap, then if we want to add, then r is equal to a plus b, and if we are adding, then we can write them this and rearranging the terms ax plus bx I cap plus ay plus by j cap plus az plus bz k cap, or r can also be written as rx, ry, rz. So we can write this, and by comparing we will get that rx is ax plus bx, ry is ay plus by, and rz is equal to az plus bz. So that is all. Now these are the three numericals from your NCERT textbooks, solved examples. Try to solve yourself and take the help of NCERT textbook also, but still if you have any doubt, you are free to ask me any time. So that is all.